All right, guys, welcome back. So if you press play, you realize that we have this nice little character who's walking with classic Delhi swag. It's pretty cool, but there's more I want to do to this. I want to make the animations for walking and running a little better. In fact, when the character goes beyond a certain speed, I want him to start sprinting rather than just walking normally. So I'm just going to double click this. And as you can see, we have this event graph that we had from last time. Now I want to run you through some things. A little more about this try get pawn owner, because you might be wondering what this is and where it came from. Well, to do that, what I'm going to do is I am going to basically just redraw a few things. Now we have the blueprint. Let me just use a bigger brush, in fact. Right? We have the blueprint. Right? Remember, we have the third-person character blueprint, right? Which has the viewport, the construction script, and the event graph. Right? We know we have an instance of this. Let's just call it instance, right? Which is your actual third-person character, right? Whoever it is in game. And then this third-person character, we know, has the Delhi animation, whatever, _C file. So right now, when we're here, when we're in this blueprint, we're actually here. Right? And what we need to do is find out who owns this. And the owner of this is this person. Right? So that's what we're doing when we're doing try get pawn owner. We're trying to get the owner. But ideally, what you want to do, just to be safe, is not just get the owner, but also get the class that the owner belongs to, which means you need to do a cast to, like we've used in the past. Right? Which is we need to try to get where is the blueprint? Who's the blueprint owner of this? And is that valid in the first place? Right? So we'll do this. And try get pawn owner, which will get us the instance. Let's do cast to third person character. Right? Let's just move all this to the right a little bit. Right? So let's cast to third person character, and then we check if it's valid and move on. And the reason we're doing this is later on you might want to use some stuff as the third person character. So you're just making sure you get the original blueprint rather than just getting stuck at a particular instance, right? So this is a good practice. Even though it'll work without casting, it's still a very good practice and it's necessary for you to know. And if you don't understand it fully, don't stress out about it, because when we start using this in the future and we start using the variables in the third person character, then you'll understand why we brought this in here. All right. So now we've got the speed, right? We've got the speed of this character, and that's great, but we also want the direction of the character. Right now we can't tell, let me just clear this. We can't tell if the character is going, which direction the character is going. We just know he's going fast or slow. That's the only piece of information we have. Now, we're working with vectors, right? And for those of you who haven't done enough mathematics or who haven't studied any sort of physics or even advanced math, you guys won't know what vectors are. So it's not particularly necessary for you to know what vectors are, but I want to give you a very, very, very short crash course, right? So there's a process in vector math called normalization. And in the resources, I'm going to link you to what normalization is and how do you actually do normalization. But the general idea is that if we set the magnitude of a vector, and we have a vector right now, it might be something like this, right? So if we draw axis around it and we set the magnitude to 1, then what is the direction of the vector? What we're looking for is the direction, right? And the process of finding direction in a game is actually the same process as normalizing, right? In vector mathematics, because we're working with vectors here. So what we want to do is, getting this pawn, we want to get the owner of the pawn, which is the instance, and we want to find out what is the direction of that pawn, right? And the way we'll do direction is we'll use two axes, -180 and +180. In fact, two ranges, two endpoints, right? And we'll do this the same way on this axis too, on the y-axis too, +180 and -180. We want to know if the person is simply moving forward or moving backward. So this would be, the forward axis, and this would be the move right axis. So we want to get the actual direction so that we're able to make our animations a little better. To do that, there is a handy little node called the calculate direction node, right? And to do that, you need to input two parts. You need to input the vector length, and you need to input the rotation. So what we're going to do is, from try get pawn owner, I'm going to pull in get rotation, get actor rotation, right? So we've got the rotation of this spawn owner, and we're going to feed both these values, both the velocity as well as the rotation, into a new node called calculate direction. Alright, now don't get confused by what calculate direction is and what it does or anything like that. Calculate direction is just normalization, right? And eventually you will get the hang of what normalization is. Please look into the attached resources, because normalization is, it'll take about 10-15 minutes for you to understand what it is. It's just simple mathematics, right? Nothing to confuse you about. In fact, this is a better way to learn what normalization is than, you know, looking at it in some sort of book or anything. Alright, so I'm just going to send the velocity here too. And I'm going to return this value, and in fact I'm going to set a new variable. Let's call this direction, and I'm going to make this a float 2, right? Just saving the direction, and I'm going to set the direction, right? And we'll set it after we set the speed. Doesn't matter which order we do it in, and I'm going to set the value to be this, right? So I'm just going to show you what this looks like when I print it, right? Let's just print it to show you what this direction is. So we set both these values, save, and play. As you can see, right now the direction is 0, but you can see that when I'm moving backwards, the direction changes. When I'm moving left and right, the direction changes. So this direction is a way for us to find out where the character is moving in real time. So we've got the direction, we've got the speed, and sometimes the direction will go negatives when the character is moving backwards or moving to the left. And what we're going to do is we are going to use both these variables, the speed and the direction, to make a new type of animation. So let's open our anim graph, let's open our state machine, and let's go into walking/running. Now we have a single animation playing here, walking_1, and that's going to play regardless. But I want to create an entirely new type of animation, but because I don't have 3D modeling software, or we're not going to 3D modeling software right now, let's create one in Unreal itself, combining these animations. So what you do is right click and go to animation and look for blend space. Now there are two types of blend spaces. One is a one-dimensional blend space, and the other one is a two-dimensional blend space. Since we have both the speed and the direction, let's use a two-dimensional blend space. I'm just going to click on that. Obviously we're going to use this skeleton, not the other one. And let's call this walking running underscore 2. Actually, let's name it BS underscore walking running. Right, this is actually the right way to name blend spaces. You use the words BS, or you use the letters BS before it. And you know, this is going to be empty right now. There's going to be nothing. It's just going to be idle. But we'll work on that in a bit. Right, so let's go back to our Delhi animations, and instead of this play walking_1, we'll delete that. Let's take this BS walking_running and let's place it here. Now there are two variables that it needs, but you know, that's because it's a two-dimensional blend space. Blend spaces are either one-dimensional or two-dimensional, but we haven't named any of this. So let's start editing this right now. So either you can double-click this, or you can go here and double-click this. Both of the same thing. So we want two axes, right? We have a horizontal axis and we have a vertical axis. In the horizontal axis, let's call this direction, and the vertical axis, let's call this speed. So speed, and you can just go here, and if you're not able to click here, hold the shift button so you can. You can also release the shift button once you're already in here. Look at this, the speed here is 0 and the direction is 49, right? And the speed here is, you know, 99 and the direction is 49, and that's because we haven't set these values, right? So direction, like I told you, let's set it between -180 to +180. Let's set those bounds, -180 on the left and 180 on the right, which means at the center the direction should be 0, right? And on the speed, let's go between 0 to 600. Remember, we have the third-person character blueprint. Well, one of the things that's hard-coded into that blueprint is that the maximum speed is 600. So let's leave that as 600, right? This should be good enough. So obviously, if you go on top, that's the speed of 600. At this bottom, it's a speed of 0 and a direction of 0. Now what we'll start doing is we'll start making an animation from the animations that already exist here. So I'll take the idle animation. When the direction is 0 and the speed is 0, we want the player to idle, right? We want to, actually not the running. Let's take all the idles. Let's put the idle, because these are all speed 0, right? At 0 speed, basically, no matter what the direction is, we don't want any other animation to play. So we'll just have all of this to be idle. Right? Now what we want is when the speed is at some amount and the direction is still 0, then we want the player to walk. So we'll take this walk and we plant it here. Right? So speed 300 but direction 0, walking forward. And obviously when the speed is 600 and the direction is 0, we want the player to run. Right? See how cool the player is running? So this is a blend space, right? Look at this. Look how it blends together. So depending on the speed, the animation changes, and at every frame, it's trying to kind of calculate the midpoint and get you all the way smoothly from idle to running across two animations that Unreal doesn't even know about. That's the beauty of this engine, right? There's a lot of things that it does which you'll only know if you start digging into the engine. Now, at both ends of the spectrum, which is, when the direction is 180 or if it's minus 180, we want it to be walking backwards, right? So let's just pull walking backwards on both sides. So as you can see, we want this smooth walking backwards. There won't be too many instances when you walk backwards, but that's okay. We'll still have that in, right? And obviously, we want it to be run backwards, but one thing I found while I was doing some testing is that this animation is flipped, it's reversed. So if I put this, where was that? Yeah, if I put this run backwards here, you'll see what happens. Let me hold the shift key. Look at this. It goes from here, and then some random stuff happens to the animation. It's because this animation is broken from Mixamo, so I'm going to delete it, and instead I'm going to use the walking backwards animation still. Right? So it'll be happening a lot faster, but that's okay. Right, so we have this nice little, going from running to going backwards. It's a decent blend. It's not the best blend, but it's decent. We'll save that, and now we need to input two variables into this, the direction and the speed. Luckily for us, we've already calculated both. So get direction and get speed. Right, so we'll connect the direction to the direction and the speed to the speed. I'll move this down just for the sake. Okay, now if you play, you'll see that this is much smoother for you to do. Right, so the player goes all the way from walk to run. It's very subtle. You can't notice it easily, but it's happening. One thing I want to do, and if you play, you'll see this, right? When you stop, it's very jerky. It just stops immediately. And that's because it's not blending between the two animations. To blend between the two animations in our blend space, between any other animation and this one, we are going to set the interpolation time. The interpolation time is, well, how does this animation blend with the previous animation or any other animation? And we'll set this to maybe 2 seconds. Right, we'll just set this to 2 seconds just to be smooth, so that when we stop this animation, things are nice. So, bam. You see? I think 2 is a little too much. Hang on. Let's make this 1. 1 should be better. See? There's a nice little blend into this. And he goes from walk to run. Right? And you're running. So, he goes from walk to run, and it's a smooth blend, and there's a nice interpolation. Even when he stops, he doesn't just throw his hands down like before, he stops it slowly. So this is what I kind of wanted to show you guys in this episode, and in the next episode, let's continue with animations like jump and punch and so on. Bye-bye.